Okay, good day everyone. Thanks very much for joining us today for this joint webinar with Red Hat and Eurotech hosted by the IoT Solutions World Congress. My name is Benjamin Radigan and I'm helping to plan the IoT SWC here at the Theatre Barcelona. With me today are James Kirkland from Red Hat and John Woodland from Eurotech, who will be discussing their recommendations for implementing converged IT/OT infrastructure, including technology considerations, addressing scalability, availability, and security challenges, architecting to provide dynamic intelligence at the edge, streamlining data formats and simplifying integration, and acquisition, aggregation, and processing OT device data. So we'll go to the next slide now. Okay, for those of you unfamiliar with the IoT Solutions World Congress, the event was born out of a need to gather together a large grouping of people interested in industrial IoT in a full Congress and exhibition setting. Here, the focus is exclusively on industrial IoT, and with our program partners, the Industrial Internet Consortium, we're developing a second edition of the event for October 25th to 27th of this year, with the expectation of more than 8,000 visitors, 120 exhibitors, and 200 speakers. We were very glad to have Red Hat as one of our silver sponsors for the inaugural 2015 edition, and have had a very positive experience collaborating with them. So, by way of introduction for the webinar today, James Kirkland is Chief Architect for the Internet of Things at Red Hat. James is the advocate for Red Hat's initiatives and solutions for the IoT, and also serves as the lead subject matter and global team lead of system architects responsible for accelerating IoT implementations for customers worldwide. James is also a member of the IIC and is also a contributor to the IoT working group of eclipse.org and is a frequent public speaker and author of a wide range of technical topics.
Well, thank you so much for the invitation, or introduction, excuse me, Benjamin. For those of you who aren't familiar with Red Hat, just a general overview of who we are and what we do. We're obviously, when you think Red Hat, you think Red Hat Linux primarily, but we have products that cover really a much wider range of technology areas, including cloud, storage, obviously operating systems, but also middleware and virtualization. And you know, we're the first billion-dollar open source company in the world, and we are, you know, we have our solutions in more than 90% of the Fortune 500 companies use either our products or solutions. So it's great to be here. I really appreciate it, and look forward to the discussion.
Okay, excellent. Thank you, James. Next, I'd like to introduce John Woodland from Eurotech. John is the Director of IoT Solutions at Eurotech, where he is responsible for building partnerships, distribution channels, and large customer deployments of Eurotech's Everywhere Cloud Platform, which is an M2M IoT integration platform, and helping guide the evolution of the platform capabilities to anticipate customer requirements.
Great, thank you for that introduction. Just a little bit about Eurotech. We were a company founded in 1992, primarily in the embedded space, so we build single board computers for embedding into products. We've been around since that time and growing our facilities out globally, so we now operate in 3 different continents, and we have, over the time, we have grown from making hardware to understanding that that hardware needed to be connected to something. And so we ended up investing in software development. Back in 1999, we co-developed the MQTT protocol with IBM and then open sourced that. We've continued on that evolution of our software to continue to try to make IoT less complex. And last year, back in September, we open sourced a framework, a gateway framework called Cura in Eclipse. And so we are a software company in and of its own right outside of our hardware platforms that we build. You'll primarily find us in industrial settings, in transportation, in defense, and healthcare, places where there's a need for high reliability or places where things reside in dirty, nasty environments that are hard to get to and just need a long life. That's primarily what you'll find with us. But with our software platform, we've grown that out much larger. We've had third-party companies come to us and you know, license our software now, and so we're seeing our software pop up on other people's devices. They're in whole new verticals than we ever anticipated on being, and so we're very excited to be here today with Red Hat, and thank you so much.
Phenomenal. Thank you, John. Okay, so without further ado, I'd like to invite James and John to take over and let you know a bit more about how converged IT OT can benefit your businesses.
Okay. James and I are going to bounce back and forth through this presentation, so hopefully we get the bouncing right and don't overtalk one another here. But I'll start out with this first slide, the Internet of Things, just to sort of set the stage. The Internet of Things, you know, a lot of people are talking about what is the Internet of Things. Way back in 1990s, our CEO, Roberto Siagre, coined the term of pervasive computing grid, and this is the idea of computers would disappear into our everyday lives and be so invisible to what we were doing and be communicating that they would transform the way that we live. And that has taken an evolution, of course. We knew it as distributed computing for a while, then it became M2M, and now IoT. With M2M, what we really saw is single machines talking back to single databases as a relatively simple architecture. But now with the introduction of IP into this and the opening up of the Internet as a vehicle to actually communicate, now we're talking about different machines, different protocols, talking to other machines with humans attached, and so really now become almost anything that you can think of that we can attach to the Internet. And it's created a lot of complexity on how we bring in not just new architectures, but also take in those legacy architectures who are very dependent on you know, very vertical protocols. And so that's what we're going to be talking about today, is sort of the evolution into the Internet of Things, the complexity that sets up, and how we deal with it. James?
Yeah, and the other thing I wanted to add was just a base definition of what IT and OT are. And I think it's important. We'll go into this in more detail. Operating technology is typically going to be run out of, and we talked about IT being part of the CIO's organization, running core business applications, and you know, traditional computer workloads that are going to be centralized in a data center. Whereas OT is operational technology, is typically going to be run out of the lines of business themselves. So if you have a company that has a factory, there's going to be a division that runs manufacturing. There's going to be a vice president or a president that's over that, and those technological decisions are made within that. You know, within an energy company, you may have a transmission department that's responsible for transmission. That line of business, a generation line of business, you know, those different pieces. So if you look at what's driving enterprise or industrial Internet of Things, you know, there's multiple strands that have come together over the last few years to really enable it. If you look, companies like FedEx and UPS and the military, you know, they've been able to have things that were you know, paleo Internet of Things, but they cost, you know, hundreds of millions of dollars. What's made it available to your average enterprise or company is you know, several trends. It's explosive growth in connected devices. So you've got, you know, driving that ubiquitous Internet connectivity through cellular, Wi-Fi, you know, whatever that the mechanism is. You've got affordable bandwidth that's there so that you're able to connect all these devices together. And those devices themselves are commoditized, they're standardized, they're relatively affordable. So you've got microcontrollers, you've got systems like the Pi, up through things like Intel Atom, Intel Core, and then you've also got a wide range of electronic sensors that have become very affordable and are mass-produced and easy to build. And then you've also got advances in cloud computing, decreasing the cost of storing and processing all this data in the data center itself. And then, most importantly from my perspective, I'm a little biased, but it's standards-based and open source software. If you look at cloud computing and you look at the Internet of Things, the backbone of both of those are going to be standards and open source-based software. And John, if you could talk about it a little bit from your perspective, what examples and where you're seeing it being driven as well.
Yeah, I'd love to. Thank you, James. I spent the first 15 to 20 years of my life in IT, and then I moved over to OT, and specifically IoT business about 8 years ago, and I've spent the last 8 years focusing in on this area. And it's really interesting. I can remember 8 years ago opening up weather stations and finding Nextel phones that were cracked apart with the board actually soldered into stuff, and they were trying to use the data path through the Nextel phone. And one of the things I think that characterizes OT is that they will grab whatever's off the shelf because they're trying to drive a lot of different things for the business, right? They're trying to innovate. And with the availability of technology that they can innovate with, they come up with amazing things. And so over the course of the past several years, what we've seen is proliferation of things like Raspberry Pis that are readily available, sensors that you can buy off of Amazon.com, and what we're seeing now is actually OT is recognizing that hacking a phone that might last a year, and then you got to redo your whole hack on a new type of phone. That's probably the wrong way to go. Traditionally in the OT environment, truck rolls are a bad thing. You want long life products, and so now developers are developing on Raspberry Pis, BeagleBones, whatever, Arduinos, and they're getting their solutions up in a sort of a pilot concept, and then they're trying to take them to market. And what they're finding out is when they take them to market in those developer maker models, it's not scalable into something that would be a production. It's not consumable by the enterprise in a way that IT can actually absorb it. And so now we're actually pushing back down into OT to try to figure out how we standardize this approach and bring OT up into these commonly used standards, commonly used tools within IT. And so it's a very interesting nexus that's coming together between IT and OT as we converge these two environments.
If we then look at what's driving enterprise IoT, there's the technological reasons it's possible. The things that are driving it, first and foremost are economic gains, better return on assets, decreased costs, things like that. But there's other reasons as well. There's going to be new revenue streams from product innovation, so that there's going to be new categories of products that we hadn't thought of, 5 or 10 years ago. They're going to be available by companies to their customers. There's issues of regulatory compliance, privacy, a lot of these things that as people get onto these connected devices, they're going to need to be able to have more insight into what's going on across their enterprise, and more control over what's going on across the enterprise, across the entire company. And then, there's efficiencies and productivity. So as we talked about, you want to lower costs, but you also want to lower risk, and that risk may be life and limb, that may be a risk of something, horrible happening, which causes lawsuits. It may be, a wide range of risks. It may be risks related to competitiveness and failure to notice trends within your own business or within the larger operating environment. There's also the ecological impact as it becomes more and more important for things like climate change and these different pieces. It's really important to be as optimized as possible and get the most output of every piece of, whether it's fuel or natural resources that go in. And then there's customer satisfaction and ease of use. The more information, the more engaged you can be with your customers, the more important, the more you're going to be sticky, the more you're going to be able to have that customer want to interact with you versus the competitors and competition. So John, maybe if you could talk about some use cases and customer experiences and examples.
Yeah,
be great.
Thank you. Yeah, I think one of the interesting things about this is in the traditional M2M world, we would talk about one of these things, right? In IoT, we're talking about the mashup of all of these things coming together. As an example, we recently won an award at ID TechX that was based on a customer that we put an end-to-end solution together for. They make boiler systems for consumers, for homes. And in that instance, they wanted a sort of a Nest type of capability where people can monitor their heating systems. But in addition to that, they wanted to take advantage of giving the consumer back information about their energy usage so they could be more ecologically knowledgeable about what they were using. At the same time, they wanted a back-end feed in order to create a trouble management solution so that their service teams can actually proactively manage those boilers. And at the same time, they wanted to get a quality service feed that pushed back into R&D so that R&D could take a look at the problems, the failures on the devices, and actually make a better quality product. So it's interesting because in 5 years ago, we would actually cost justify one of these solutions based on one use case. And today what we're seeing is the mashup of different use cases and the way that the data will be used across the organization is creating an astronomical effect in terms of the return on that investment. And it's also set up some complexity with the decision makers, but in general it's a really good thing, and it's increasing the demand for rolling out these solutions. So I'll take this. I'll start out with this slide and talk about the edge. This is where Eurotech has our most experiences, really in the working from the device in. We've got a lot of experience in embedded products and putting intelligent systems down at the edge. And what we've seen over time is when M2M started out, it was a simple sensor talking back to an application, and anymore it's a lot of sensors, a lot of dissimilar sensors running different protocols perhaps that are being pulled together and aggregated across the common infrastructure, WAN infrastructure, and pushed up into a big data play. And with this, it sets up a lot of complexity, the complexity of what data is the right data that you need. And so our belief is that intelligence needs to be pushed and continue to be pushed down the edge. This goes back to our original theory when we started the company, that we would see intelligent systems that sort of disappear into our everyday lives and all communicating together. And so at the edge, we feel that there's a certain need for intelligence down at that layer to do rules-based management, to provide analytics, and so that when we push data up, we're pushing the right data up into the cloud and into the big data platforms so that we can optimize the cost across the WAN. We can decrease just the complexity of the data that's being managed up in the data centers. And so that's really a big push of ours, is to recognize the ability of the systems to deploy and maintain intelligence and update intelligence at the edge.
Yeah, and I think one of the key points that you alluded to is that it's really important to get the right data to the right place at the right time to make a decision, and that may change over time, or it may change based on condition, and you've got to have the intelligence throughout, and we'll talk about this as we go further through, but you've got to have the intelligence within the system to be able to route data, whether that's being able to make very quick decisions at the gateway or the device to optimize the system. It's about batching data to make sure that you're not flooding communication channels and causing lots of telecommunications charges, or flooding out important data with garbage data. And then it's got to be at the right point, at the point of decision, So you need to make sure that the data is routed to the right place. And John, if you could maybe talk to us a little bit about the complexity of IoT, because I know that it is a big ball of hair.
Yeah, absolutely. Thanks, James. Yeah, when we look at the complexity of IoT, right, it was very simple taking a sensor and pushing the data back up to a database across a known, WAN infrastructure. That wasn't very difficult. But now the people are recognizing that data can be used in different ways, that there's more stuff out at the edge that we could aggregate together, especially if we can put intelligence at the edge. It's set up a very complex solution architecture, if you will, where before we had monolithic applications built from the application layer all the way down to the sensor. That's not possible anymore. It's not scalable. You have to break that apart. You have to decouple it, if you will, so that you can deal with all of this complexity. Otherwise, you have this spider web of connections going on, between applications that all need that data, and also between all of the different sensors and edge devices back up to multiple applications. It sets up a tremendous amount of complexity, which impacts your ability to scale your platforms. It might be simple to manage when you're a couple hundred devices, but when you grow into 20, 30, 40,000 devices, not only dealing with that mass amount of communication connections is going to be difficult, but also dealing with the management of those lower level devices becomes increasingly difficult.
Excellent. So, as we look then and sort of talk about the two different silos that we have traditionally, you've got on the IT side, we talked about it supports enterprise applications, office workers. It's very centralized. I mean, that's generally the way that you see it and the way things have evolved. You're going to be running enterprise resource platforms. You're going to be running customer relationship management platforms, business intelligence. You're going to be running mobile application infrastructure, web infrastructure, all those sorts of things. But it's very generalized. So the goal is to standardize as much as possible, to not replicate 10 different ways of doing things in different environments. You really want to drive cost out by having a total systems approach with interconnected applications and generally open standards, an open architecture, and you want to reuse as much as you possibly can. And the CIO, their primary remit is efficiency, driving cost out, and providing services at the lowest cost per unit. John, maybe if you could talk about some of how the challenges differ in the OT world.
Yeah, thanks, James. While IT has been challenged with keeping the systems up at all costs, which has really driven a need for maturity in all of their processes and systems and the protocols, the standard protocols that they use in a very horizontal approach. OT has been driven by a need to move the business forward, either by decreasing costs or creating efficient revenues, top-line revenues, or driving out to a regulatory impact that is looming over them in a fast way. And so traditionally, OT has started out by grabbing whatever is available off the shelf and deploying it. They characterized by very verticalized protocols for very verticalized applications. And so they've rolled these up without necessarily the understanding of the need to actually manage them horizontally and work them up into the enterprise systems. And this is created an impedance to scale out. It's created a long-term problem with management of all of those devices. Like I mentioned before, when you've got 100 devices, it's not bad to know where to send a truck or whatever. When you've got 20, 30 devices that are all sitting on poles, it gets much more complex to know where to send a truck or how to upgrade software or anything like that. So those are some of the challenges that OT has has dealt with, but they've been forced to do this. This has been out of necessity because the primary goal was to get to market quickly, to create a competitive edge, either on the operations side or on the revenue side, or to meet that regulatory impact at as low a cost as possible. So these are the things that they've been dealing with, and this is what's made it difficult to bring these two distinct silos, the IT groups and the OT groups, together, because fundamentally they look at their businesses in different ways.
And John, if you could talk a little bit about how the technology silos inhibit innovation, that I think that's really key.
Yeah, these misunderstandings on both sides have sort of, it's not been easy to embrace, right? As IT has looked down into OT and said, how am I going to deal with all of these different protocols? It's been a challenge, right? So OT organizations have to be able to take advantage of the rapid advances in IT feature functionality. As OT is able to bring their services back up into the IT world and get more maturity around them, they'll have more ability to manage them at scale, and they'll end up driving a lower cost. The challenge is how to do that in a world that OT is used to, which is rapid deployment. And so that's what we're really doing by bridging these two together, is bringing the needs and requirements of OT together with the needs and requirements of IT to create a best-in-class approach to bridge the two silos.
And one of the issues is from an IT side is that IT is not used to the long length of support that's needed for these, and is not used to, as we talked about, supporting the variety of implementations. Standardization is key, and I think it's really important that IT has to find ways to be able to bridge these gaps. Whether it's through integration products or projects or whatever that is, it's really really important that IT become more flexible and agile in how they deal with this, these problems. That they have also got to find potentially new ways to do this, pairing projects together with OT organizations so that they can share funding, share goals, and share the outcomes and opportunities that come from them. So, John, next we talk about the benefits of the converged infrastructure. What from your perspective are the key things?
Well, I think if we really talk about the converged infrastructure, we're really talking about bringing the best of IT and the requirements of IT forward into the requirements of OT and mashing those two things together. So with this, we'll get improved decision making, because instead of actually moving data back into one system, one application for one group to take a look at, we're now able to share that information across multiple groups, so the business as a whole can take advantage of that data, and maybe even repackage that data and sell it to other people that would need that data and create revenue streams off of it. Where traditionally, when OT would go out and engage IT, it might be an 18-month delay in what they're doing in order for IT to really get their hands around the project and actually create maturity around it and understand how to bring these protocols in. And it really was a detriment to OT's ability to actually meet market demand. And now what we're talking about is giving IT the tools to actually have that rapid development, move that development up into a production environment that is able to be managed through the common tools that they have, and reduce risk to the overall organization. So really what we're talking about is bringing the best of both worlds together in a seamless manner, so that we can take advantage of everything the OT needs and take advantage of everything the IT needs.
Excellent. And So we're going to sort of start to walk through this chain diagram here and begin talking to the critical areas for IoT success. And John, I think that starts with you know, from the device layer and coming up. But if you'd like to sort of walk through that, that'd be great.
Yeah, absolutely. Let's start with the sensor area, right? So when you're taking sensors and you're putting them into a gateway or some type of aggregation device and trying to push that data up, there's a number of things that you want to you know, deal with, all the way up through where you hand it off into the application. So if we can go to the next slide really quickly, slide 14. Let's talk about this, the first complexity layer, which is at the edge, right? You've got multiple decisions to make. You need to make decisions based on what operating system you're going to support, and it has far-reaching implications. If you're writing in C, C++, you're writing on top of Linux or on top of Windows, you're writing your applications or your edge drivers down into things that are very hardware constrained. And so you're making dependencies on that hardware that will live with you over time. So one of the things you have to think about is what's going to happen when that hardware is end of life and you have to replace that hardware. Are you going to have to rebuild your application or at least your edge applications to take advantage of those drivers or those new sensors that you're bringing in or the new equipment that you're changing out? What also happens when you want to bring in new services from the edge? So let's say you've designed your system for one sensor to come in. You know the drivers, it's a known quantity. You've written it down in the Linux kernel and you've made all those adjustments, and now you want to actually add a few more things, maybe even adding video into that. How does that impact the overall you know, infrastructure and architecture that you're putting together? So that combined with the need to actually push down business logic changes the way that you might want to take a look at the edge. And we believe in sort of trying to abstract that, because in our world, even when we've done simple things like gone and certified a box with a carrier and then had to change interfaces on that box, it's forced us to go back and recertify you know, that box with that specific carrier. So it's created a lot of delay in the cycle, and these are things that you need to consider. If you go on to the next slide, please. Moving up the stack into the WAN or the northbound interface out of the gateway, you need to worry about what end-to-end protocols you're using. How do you best aggregate all your data streams together? And how do you manage those data streams and consolidate them so that you're only sending the right data that you need up across the WAN? You're reducing your cost on your WAN as much as possible. The ability on the WAN is becoming increasingly more infinite as we move forward. We were at a carrier last month and they showed us I think it's 110 megabit download speed, you know, coming out across LTE. So the technology is getting better. The latency across that is getting much better. The impact, the cost per megabyte to drive this stuff is getting much better. So it really opens up a lot more opportunities than it has in the past. But with that, it also opens up more complexity. Do you go cellular? What form of cellular? Do you go Wi-Fi? Do you go Ethernet? What do you use? Or is it a combination of all of that? And that's what you've got to come and decide on. And finally, when you look at that edge device, you've got to worry about not only the southbound security, the security coming into the gateway, but you also have to worry about the physical security on the edge. So you have to have a layered security layers into your overall enterprise security policy, and it's something you need to contend with, because what we are doing is potentially opening up the whole end of the enterprise. If you go to the next slide. When we move up in the cloud, this is where I showed you that slide with that spaghetti nest of different, and it becomes infinitely more impossible as you add devices and add applications at the northbound side to manage all of that. And so what we really profess is that you need to try to decouple the producers and the consumers of the data and abstract that in a new way. So creating a middleware of sorts that allows you to actually take data in, normalize it, and then push it out in a publish subscribe type of manner for the northbound applications to retrieve that data as they need. But while you're doing that, you need to be aware of write speeds to the data. How do you handle real-time data streams and actually making those real-time data streams successful and capturing all the data from them? It becomes a complex situation that you're dealing with. Should go on to the next slide. Finally, device management. Device management is something I frequently find people in OT are sort of disregarding early on, especially when they're starting out sort of in a maker environment. They're not concerned about this. But again, like I say, it's easy to manage 100 devices out there, but when you get to 1,000 to 20,000 to 30,000, I've seen the inability to manage these devices and the need to run trucks out to find all of those devices has actually brought down companies. It's increased their operational costs far beyond what their revenues would support. So this is something you need to be aware of. You need to be able to manage the devices. You need to be able to manage the applications that are running on the devices. You need to be able to upgrade firmware, all remotely. And while you're doing that, you need to also be aware of the security infrastructure and the security policy that you're working in, so that you're not opening holes up either downstream into your device or upstream into the enterprise application. So James, do you want to talk to us about security and the API levels?
Yeah, so one of the big challenges we have is that there is a point, whether it's at the gateway, whether it's at the edge of the cloud, where you're going to have the OT and the IT worlds come together now. And so it's important that we have, standardized security policies across the board. So, and you have to have a context around all of the data that is moving. So you have to, you have to know whether it needs to be encrypted in flight, encrypted at rest, who needs to have certificate-based authentication, are you using trusted boot? So all of that stuff, are the images signed? All that stuff has to be consistent across the way. Otherwise, you're going to be in trouble. And you have to have a layered approach to security. You have to be able to handle it, basically so that you don't have one single point of failure, essentially. Some of the other ways to handle this would be, to handle controlling this infrastructure is through APIs, right? You need standard APIs to be able to address the device, to configure and change the device, to be able to manage the device, the gateway, how messages are flowing through the system. You have to have a standard set of APIs that your developers are going to be able to develop against. Otherwise, it's going to be chaos. So it's really important that you look at these APIs when you're starting out. Otherwise, you're going to be trying to retrofit that back over the top. You need to have pluggability, and you need to have the ability to have adapters for standard applications, so that you're able to have, and we'll talk about this a bit more in 6, but you're able to have business rules that are outside of the core business logic that you can change based on business conditions, and those need to have sliding windows so that you can look forward and look back at events, so that it's not just if this happens, then do that, but if this happened 5 times over the last 10 minutes and that happens, then do this. So you need to have the ability to look at more complex timing than point in time. You need to look at sliding windows. So, we'll talk about how, as we go through, how to accomplish that, but things like business rules management, complex event processing are really key. Because you've got to be able to have some dynamism that's outside of the standard, firmware update or patching cycle, the ability to push logic down into these applications and to interconnect things, at the gateway layer and at the cloud layer. So when we look at the business application integration, first you have to have an application development lifecycle and management lifecycle that's going to span everything. You need to be able to develop applications for the cloud and at least down to the gateway layer in the same development cycle using similar development tools. You're going to need to be able to integrate the data flows between all these applications using something like an ESP. So you may need to put up a REST interface. You may need to have messages routed with predetermined capabilities. You may need to interface with, say, an ERP. You may need to interface with Salesforce as a CRM or whatever. So you need a pluggable, standards-based way to do that. You need to have dashboards, user interaction, and easy ways of interfacing with data the way that the users want to. So mobile applications, web dashboards. You need to be able to put these up and maintain these as part of the application device or the application development lifecycle as well. And then you need to be able to integrate with data lakes, data pools, pulling the insight that's gained out of big data back in, both, through the dashboarding, business intelligence, and also through creating new rules and complex event processing that's and pushed back down through the gateway and down into the devices so that it's dynamic and not a static network. And then you're also going to need, especially in certain verticals, you're going to need to integrate with social networks. You're going to need to integrate with the outside world so that when events happen, you may want to tweet the world that there's a power outage somewhere, or that there's a problem somewhere, or that there's a new service available, or when you look at things like surge pricing, all of these are going to be affected by data that's coming out of the Internet of Things and off of these device streams.
So if we look at this end to end, we have all of these sort of modular pieces of this equation. That's what makes up IoT. That's what everybody's familiar with, right? And we have very specific companies that are addressing one part or two parts or three parts of this, and so it's possible to build one of these stacks with using best-in-class providers across each one of these, and trying to stick them all together, stick seven different providers together, if you will. What we found is it becomes very difficult to manage all of those providers within a stack. And so our belief is that when you look at this, look for somebody who can provide you this sort of end-to-end integrated view in a very modular approach. So between Red Hat and Eurotech, we've approached open standards approach to every single layer of this that's modular in nature, so that you're not becoming overly leveraged on one partner, but you're also not trying to become the integrator and trying to pull together 7 different discrete companies in order to create sort of this end-to-end solution. The goal is to find 1 or 2 throats to choke that you can pull this all together around, that have best-in-class software, but also have this modular approach that, if needed, you could either take it on yourself, you could assume those responsibilities, or you could look for somebody else to layer into this solution. But this is what Eurotech and Red Hat are providing together. If you go to the next slide, you'll see that we're integrated at every different layer. This is the proposition we've put together, is taking Red Hat all the way down into the OT environment, and then extending Eurotech's capabilities all the way up into the IT area, where we use best-in-class software from each company that is tightly integrated together to create a total end-to-end value proposition.
And I think that's really key, is the coordinated capabilities that we have bring so much, that you have the best of OT technologies and IT technologies coming together to be able to create a unified infrastructure that's going to solve a lot of these problems. If you look at the the core of this, John, what do you see are the keys to the unified infrastructure?
Well, I think the keys are multiple, right? I think it starts with understanding the value of an intelligent edge and being able to aggregate information and actually pre-treat information before you push it up into a gateway. And you do that through pulling all this stuff together with an intelligent gateway, and then pushing that gateway up into an infrastructure, a cloud-type environment that can actually take that and parse it out or broker it out to the different applications that might need it, as well as provide you a management structure down into the edge that allows you to actually update, change firmware, add new applications, add new business logic, and and change out your edge as needed without having to go through and change the entire architecture of your solution.
Yeah, and I think that's key. I think it's important to understand that you have to have an intelligent gateway out in the field to be able to extend the scope and breadth and ability of IT applications to be dynamic and change and utilize that data. But you also have to have the ability to manage and control and secure the devices that are out there. So I think it's really important to have on the back end an open hybrid cloud that's flexible and that gives you the best in data center technologies. But it's also important to have a consolidated application development lifecycle that gives you similar tools that extend out into the enterprise onto the gateway. Otherwise you risk the problems that we've alluded to, which are you deploy a solution that works for today, but it can't extend to tomorrow.
So in this integration platform that we're showing, this is our proposition that we're building together. And at the edge, at the operational technology side, you have a bunch of devices and gateways that are pulling up sensors and pulling forward other devices. You might have rugged mobile computers, all running Red Hat Linux and all running what we term as ESF, or the open source name for that is Cura. Within that, we've got, that doesn't show it here, but we've got Red Hat Fuse integrated in at the edge, and that pushes information up through an MQTT protocol, a pub/sub type of protocol, up into Everywhere Cloud, which is also an integrated solution along with Red Hat. We use the AMQ brokers, we use Red Hat Fuse, we use BRMS, within the Everywhere Cloud to create business logic and create capabilities within that that middleware. That middleware is important for managing downstream in your devices and getting right down into a Linux command prompt if you want, and being able to securely update firmware, software, applications, whatever. But it's also important for moving upstream and normalizing the data so that topics can be pulled off by the applications and pushed into the enterprise in a secure manner.
And one of the real keys is by having the Fuse and the BRMS, Business Rules Management runtimes, down on the gateways, you're able to pull that core application logic, as we talked about, out of the application. The application goes and consumes services from Fuse. It looks for and triggers rules from the BRMS runtime, and it really allows you to have dynamic control over your business, dynamic control over the data that's flowing in and out, and control over how the devices act, whether you're getting more data out of them, whether you're turning things off and on. But you get that dynamism without having to redeploy your entire platform, redeploy your entire application. You're just testing small rule sets and changes. When we look at the three-tier architectures, we've talked about it. Obviously, it can be more than just 3 tiers, but when you look at it on that endpoint, you're going to have basically communications and data acquisition. That's really what those devices are for. data acquisition and control of actuators and things like that. So they're generally relatively simple. When you look at the gateway, and there can be multiple layers of gateways potentially depending on the use case, but having at least one gateway, communications again is key, but in a different way. It's deciding what data is needed where, what data can be summarized, what data can be discarded, what data needs to be batched and sent on. So it's really routing, but at a messaging and data layer, information layer rather than at a network layer, because you don't have enough context at a pure network layer to be able to make those decisions. And then it's running real-time or near real-time data analysis, and then taking tactical action based on rules, so that you're able to, again, when you have an alert or an error or a problem, begin funneling more data to the right spot to act on it, being able to look at whether you need to turn off an engine that's overheating, whether you need to trigger a bank of capacitors, whatever it is that you need to do to control. It's a point, and it's also a survivable point, so that if the connection to the cloud and the data center goes down, you still have functionality in the field locally, local to those devices. And it's also a point where you can enforce data security, so that you can enforce encryption, you can enforce authentication, things like that. And then in the data center, you've got long-term data analysis. You're looking for those trends. You're looking for correlation. You're looking for optimizing your rule sets. You're controlling and managing the system and securing the system for long-term. You're doing long-term rule creation. You're also doing reporting and business intelligence back to the enterprise, so that they know how the system is working. And then you've got enterprise applications themselves. So you're building enterprise applications, you're integrating through Fuse with existing applications, and you're also integrating with third-party applications or COTS applications, off-the-shelf applications. So again, the Salesforces, all the other applications that you have to integrate with, Manhattan Associates, whatever those applications are. And then there's service management itself. So when there's errors and alerts, raising tickets, raising those alerts so that they can be acted on, so that you know immediately when a device fails or a comms path fails. So it's really important, and that's why we have to have the intelligence at the edge, because you're not going to be able to scale by moving everything into the cloud, because to process that data at scale, there's just not enough bandwidth to move all of the data. You're going to have a huge cost when you try to move that data at scale. I've got customers that are utilities that are having to try to shave bytes off of messages because of the cellular cost that is affected when you have millions of devices out there. You also need to reduce latency, because you're going to be needing to make decisions in a lot of cases in less than a second. So having the gateway there locally to help enforce those decisions and help make them more quickly is really important. And then to transform the data and connect it back up into the enterprise. So if you're getting millisecond readings off of sensors, you're not necessarily going to want to communicate that. You may want to average those values over a second or a minute or 10 seconds. You may want to transmit the minimum and the maximum value over every 10 seconds. You've got to make decisions when to transmit that data, and when conditions change, when to increase or decrease the amount of data. And then you have to control and manage these devices. So you're going to need to be able to have points in the middle where you can store these updates, manage how they're distributed, and basically be able to control the entire infrastructure up and down the line without breaking the bank, without flooding your communications paths, and without essentially overflowing the system and losing the information because of the vast amounts of data. John, anything you'd like to add to that?
Yeah, when we think about a gateway, we typically think about hardware. And one of the things that I'd like to challenge the audience on is to think about the gateway in two ways. Certainly you have the hardware, the physical interfaces that are going to support what you need to plug in, right? The ruggedness of it, right? The high temperature, all of that stuff that's going to, but that's just a physical attribute. What we're proposing here is a software-defined gateway that sits on top of that. And the software, the software portion of the gateway defines this overall architecture and the flexibility that you're going to have when, in the future as you decide to roll out new things. The hardware may change, but what you don't want to have to do is redevelop all of your software every time the hardware changes, right? Or hardware may be end of life or whatever. You don't want to have to go back and through that. So what we've done is we've created this Java OSGI capable gateway to create abstraction between the hardware and the functional part of the gateway that allows all of this stuff to happen. And now what we're doing is we're bringing all of the IT tool sets, the native IT tool sets like Fuse, down into that layer of the solution to give IT a deeper reach down and a deeper control without giving up all of the stuff that OT is looking for, such as time to market and the ability to take in vertical protocols and normalize that data and make decisions locally. So that's really what the promise of the intelligent gateway is to create that software capability that's abstracted from the hardware.
And we've got coming up in March, we'll have another webinar that will be covering the gateway specifically, and go more in depth on the work that Eurotech and Red Hat are putting together as partners for the intelligent gateways to be able to help bridge those gaps. And I hope that all of you join for us or for that. I'd like to turn back over to Elaine now, and I really appreciate everyone's time.
Okay, thank you, James. At this time, James and John would like to take your questions. Please enter your questions for them in the questions pane. You'll find it in the control panel on your screen. And just real quickly, James, if you can go to the next slide. While we're waiting for those questions to come in, I'd like to point out where you can learn more about our topic today. You can visit www.redhat.com/IoT to explore Red Hat's involvement in the Internet of Things. While you're there, we welcome you to subscribe to our quarterly newsletter, Inside the Internet of Things. Also, please visit www.eurotech.com to learn more about Eurotech's history with M2M and how they're applying their 20+ years of experience to the IoT. We also invite you to download our joint solution brief to read more about what you learned today. The brief is posted on both the Red Hat and Eurotech websites. The URLs are listed on the screen. And please stay tuned for more information on how to register for our webinar coming up in March. And now back to your questions. We have quite a few. One person is very interested in learning more about predictive analytics as it applies to the IoT. James, do you want to take that one?
Yeah, I think predictive analytics are really, really important because you're going to need to move from this model today, which is large, the large Hadoop clusters that are, going through and churning through this data, to, really what we're heading towards, which is machine learning and being able to predict based on, define and predict patterns, without the intervention of a data scientist with a PhD. So I think that what you're seeing more and more, and you see this with things like IBM's Watson, are these machine learning algorithms. I think that where a lot of this is going to go is to predictive maintenance. I think predictive maintenance is going to be one of the key areas of IoT where you're going to see immediate gains. And I think that we've got to amass a lot of data sets, and I think companies, industrial companies like GE and Bosch and Siemens and all these guys are amassing the data so that they can begin to figure out, with the help of these analytics companies, how do we take these data sets and find when things are abnormal. Defining abnormal is really the key in a lot of these.
So we have another question from Petra Nadova about, he wants to know, has this architecture been implemented as presented somewhere? Maybe John, can you take that?
Yeah, absolutely. We do have it implemented. We have integrated MQ into our Everywhere Cloud, and so we have a Red Hat solution end-to-end. In the webinar on the 8th, we'll be talking more about the gateway and what we're doing with the gateway. But we have current implementations leveraging the best of Red Hat and the best of Eurotech across the globe right now, and we continue to grow more. This is a relatively new partnership, and we are just starting to announce it with more coming up, and so we expect that those opportunities will only grow.
Great, and we actually have a fan on the line, someone named Greg Beeser, who says Everywhere Cloud is extremely cool. I've seen it in operation, it works, it rocks, and he wants to know, can you describe how it can be dynamically adapted to diverse IoT concepts?
Yeah, well, so Everywhere Cloud's a very horizontal platform. It's, right now we support MQTT up into the cloud, which is, a pub type of protocol that, we selfishly, help co-invent, so we're a little bit biased to it, but we are through the introduction of AMQ, introducing new protocols. We're pushing AMQ up into AMQP up into the enterprise now with Red Hat's help. So it's becoming much more broad in its ability to actually take on, legacy protocols or other protocols. So northbound, we present the data out REST API, out WebSockets, out MQTT, out AMQP. So we have a number of ways to interface northbound into the application layer or into the analytics layer off from the cloud. So it's a very flexible platform with the ability now through Red Hat for us to even grow that out further very quickly based on customer opportunities.
Great. We apologize for the technical difficulties we had earlier. We're a little bit over time, and I know some people are starting to leave. There were some questions about whether the presentation would be available. If you would like a copy of the presentation, send an email to iotquestions@redhat.com. I'm also sending that out to everyone right now. I'd like to thank you all for joining us today. I'm afraid that's all we have time for. On behalf of Red Hat and Eurotech, I'd like to thank IoT Solutions World Congress via Barcelona, our host today. We encourage you to attend the IoT Solutions World Congress event in Barcelona being held from October 25th to 27th, where the dialogue will continue regarding converged IT/OT infrastructure and other solutions related to manufacturing, transportation, logistics, and healthcare, just to name a few. Thank you to James and John for taking the time to speak with us today, and thanks to all of you for joining our call. Visit Eurotech at www.eurotech.com and visit Red Hat at www.redhat.com/IoT. This now concludes our webcast. Thank you for joining us.
Thank you so much.